This video presentation is for assembly and special machine design and the industry standards. The first section of this presentation is for manual assembly tools, the second section is for semi-automated and fully automated assembly machines. Use the requirements in this video presentation as a start for creating your own standard, as your standard must agree with your plant location, existing standards, your maintenance team, PLC, electric connections, safety code, and building code and OSHA regulation. I will start the presentation in 14 seconds. This is the Rfq letter you should use along with your request for quotation. Today's date, March 16, 2021. The due date for this Rfq, April 15, 2021 or sooner. Dear Madam, dear Sir. Your company has been selected as a potential bidder for one manual assembly tool as detailed below. You are expected to meet all the requirements of this Rfq. Be certain to read all documents carefully and send your response in electronic format to the Amer Tooling Manager. Tooling Manager, Amer Janineh. Email, amer.janineh@alamer.com. Phone, 810-542-2779. This Rfq and attachments are not to be shared with other organizations, except as authorized in writing by the Amer Tooling Manager. Failure to submit a quotation in a timely fashion, or failure to respond to this Rfq in a complete, comprehensive manner, may result in your quotation not being considered. For those declining to quote, reply no quote. With this Rfq email you have received the product 3D CAD file, the 2D dimensional drawing and the Amer standards for manual tooling. This is the scope of work. 1. Design and CNC cut 1 nest with 1 cavity for the right hand bracket and 1 nest with 1 cavity for the left hand bracket. Mount the nests on an aluminum tooling plate 1/2 inch thick. The nesting material is OBO Obomodulant polyurethane tooling board, color red board. The nest must be made of 4 blocks, 2 blocks for the right hand bracket and 2 blocks for the left hand bracket. This tool design will allow me to split the one assembly station to 2 assembly stations if needed in the future. 2. Design and construct one handheld assembly tool CNC cut to fit the clip. The handle must comply with Amer Ergonomics requirements. The standard handle part number is listed in our tooling requirements. 3. Cycle time is 45 seconds. The estimated annual volume is 10,000 brackets a year of each. 4. One operator will assemble 2 retainers clips for right hand bracket and 2 retainer clips for the left hand bracket. The operator will never assemble both brackets simultaneously to avoid mixing parts in the shipping containers. Example, if our customer ordered 200 right hand brackets and 200 of the left hand brackets, the operator would assemble the right hand bracket first. Once he finished assembling the 200 brackets, he will clean up his area and restock it for the right hand bracket for assembly. 5. The operator will assemble parts 24 hours after the molding process is done. This will allow the part to cure and shrink. The workstation will be placed in the assembly area away from the molding press. The following are requirements for quotation. 1. Include delivery time and cancellation terms. 2. Tooling cost is to be separated from capital equipment cost. Tooling is to include part of work holding fixtures and any point of operation or perishable tooling that will come in contact with workpiece. 3. Equipment startup supervision and maintenance training shall be quoted as a separate item. Specify number of days required and cost. 4. Detail of equipment warranty must be included. 5. Equipment production capabilities must be estimated and outlined in quote. Cycle time to be defined. 6. All equipment shipped to Amer is to be FOB Amer doc. 7. Quote must include a statement of adherence to the specification and include an itemized list of any exceptions taken to the specification. 8. Machine validation for fully automatic and semi-automatic to include 4 hours minimum dry cycle on vendor's floor. 2 hours run at rate with parts on vendor's floor. 8 hours run at rate with parts on Amer floor. 9 machine validation for manual assembly tool. 1 hour at the vendor facility for training, and if needed the vendor will be invited to the Amer facility for debugging the assembly tool. For fully automatic and semi-automatic machines, the vendor must provide any software or hardware, other than a standard PC, which is required to program, monitor, or control the equipment. This may be waived if Amer has a current licensed copy. Alternative assembly process or assembly tool and timelines. As a part of this quotation, you are encouraged to offer alternative assembly tool design and process to achieve better part quality, cycle time reductions to our specified request, especially those that include off-the-shelf components or industry standards, but still fulfill our requirements for fit, function, safety, and ergonomics. Timelines. Important reminder that due dates in contracts and timelines are not arbitrary and must be taken seriously. A failure to meet due dates will result in late fees, finance charges, shipping charges includes expedite shipping charges to our customers. Expedite manufacturing charges includes costs for overtime, double time, and outsourcing costs, and it can result in terminating the contract. The supplier will be 100% responsible for all costs accumulated from a late delivery of the tool. These are the 2 molded brackets assemblies. The manual assembly is for a hand press, the 2 retainers clips for each bracket. 1. Every detail related to the assembly process is to have its own item number in order of the sequences required for the assembly process. 2. Assembly instructions are to be detailed and simple with necessary pictorial illustration. A person with no prior knowledge of the part or fixture is to be able to operate the tools based on the assembly instructions alone. 3. Assembly instructions must be presented in electronic format. Microsoft Word, Microsoft Excel, or Microsoft PowerPoint are acceptable format. However, Adobe Acrobat, PDF, is not acceptable. 4. All images or pictorial instructions created on paper must be laminated and attached to the fixture via a metal notebook casing. The metal binder or casing must have a safe holder on the base. 5. Reference metal binder as shown below. 6. Tools must be free of sharp edges which may risk operator injury or result in product damage. 7. A special tag or engraving area is required on the base with Amer name and logo, including but not limited to the following information: program name and number, property of, VTAM number or asset number. Picture of the tool and tag are required after the tool is approved. Stamp weight and size of the fixture on the base. 8. Any certification and information paper tags or paper stickers set on the base must be laminated and covered with a transparent cover plate and to be attached to the base by screws. 9. Gluing tags on the base or otherwise is forbidden. 10. Fixture tools and instruction binder must be wire connected to the fixture base. 11. A steel toolbox or a cart with a drawer is required for any loose secondary tools, or if possible, any small secondary tools and devices, to be tethered and placed in secure cases or holders that are mounted on the base. 12. Supplier must provide bins for components, 1 bin for each component, the bin size to be suitable for the project. 13. If the fixture is 35 pounds or less, the supplier must provide a suitable shop cart. 14. If the fixture is 35 pounds or less, it must have 2 handles. 15. Assembly fixture base construction type. If the assembly tool's weight is 35 pound or less, use cast aluminum plate UNSA 07130, or ANSI 713.0, or equivalent. The plate thickness to be 3/8 to 1/2 inch thick with supporting feet or legs and handles. 16. If the assembly fixture weight exceeds 35 pounds, it must have legs and be designed and constructed so that it can be handled by a forklift truck and or crane. Must be placed on a cart made of steel square tubing with casters. All material to be approved by Amer engineer during the tool design review. 17. The supplier must use ergonomic handles for handheld tools, as shown below or equivalent. Handle length. The length of a tool's handle affects comfort of grip and the pressure being put on the palm of the hand. If the handle is too short, it can cause compression in the middle of the palm. An ergonomically designed handle should extend across the width of the palm and preferably be 5.5 inches in length, with a minimum of 4 inches. Longer handles are recommended when wearing gloves. Handle material. A good grip is an important factor when dealing with hand tools. Sufficient friction has to exist between the hand and handle for a good grip to be formed. The optimal materials hand tools should be made of are non-slip, non-conductive and compressible materials. A preferred material is textured rubber, for it promotes a good grip and reduces the force used to hold the tool on hand. When dealing with power tools, electrical and heat insulation properties of the handles are an important factor, and plastics or compound rubbers are optional. Handle diameter. For the optimal grip, handles should be shaped in a cylindrical or oval form. A handle's diameter varies by use. Tool used with a power grip, like screwdrivers, should be 1.5 inches in diameter, with a minimum of 1.2 inch and a maximum of 1.8 inches in diameter. A tool being used with a pinch grip such as tweezers should be 0.4 inches with a minimum of 0.3 and a maximum of 0.5 inch. These diameter recommendations are geared to prevent slippage and reduce stress and impact on hands, fingers, and wrists. Handle span. Double handle tools such as tongs and pliers used for crushing, cutting, and gripping require a handle span of 3 inches, with a minimum of 2 inches. And a maximum of 4 inches. Tools with shorter or greater span reduce the user's maximum grip strength. We recommend these handles for our project's grip Sunlight handles D2W black and gray gel. 18. When the assembly tool is used for parts with different profile, color code the fixture exchangeable components for each part number and add color-coded grooves for the different profiles. 19. The nest materials for the holding fixture contact points. To be softer than the molded part material. Nest and tools must not damage parts. Nest material to be determined during the tool design review. Example of soft materials, urethane Shore 60A, standard unfilled nylon MC907, UHMWPE or OBO modulin polyester tooling board, green board or as agreed on during the tool design. If necessary, cover all hard surfaces with sharkskin nitrile rubber sheet, AirTac F, or EPDM rubber sheet, AirTac B with adhesive, sheet thickness approximately 1/32 thick. Preliminary assembly process. 1. Injection molding. 2. Work in progress. 3. Gauge inspection. 4. Standard clip. 5. Assembly tool. 6. Assembly station. 7. Operator visually inspects the molded part before placing it in the nest. 8. Place the molded part in the nest. 9. Operator visually inspect clip. 10. Place clip in the handheld assembly tool. 11. Press the clip on the molded part. 12. Repeat the process 9 through 11 for the second clip. 13. Operator final inspection for the assembled part. 14. Place part as required in the approved container, 30 part in each container. 14. When the tote is full, move it to the pallet, there should be 12 totes on the pallet. 16. When full pallet is ready to move, the operator should call the material handler for replacing the finished product with empty pallet containers and molded part. This is a preliminary cell layout and the building assembly area layout. The image on the left shows the location for the assembly in the building and the image on the right shows the work cell layout. Please note, when you create an assembly work cell layout, make sure the operator is not locked in between the required tools for the project. The work cell must include enter and escape route, the work must include the requirements for ergonomics and easy workflow, must utilize 6S lean manufacturing, 5S and safety, use the systematic form of visual management for everything from the floor tape to the operator work instructions. This image shows the proposed work cell and the work instruction board. Also make sure that you provide actual boundary samples for good and bad parts. The work cell must have boxes for quarantine for bad assemblies, bad molded parts and bad standard components, for at the end of the shift the team leader counts the scrapped parts. The team leader must keep track of the operator quota limits, ranges, and workflow as defined by the required cycle time and the approved run at rate. If the operators cannot keep up with the required quota, the team leader must inform the process engineer and/or the manufacturing engineer for evaluating the assembly process for improvement. Establish with representatives of relevant departments functions. How will raw material be transported to the machine? How will finished goods be transported away from the machine? How will work in progress be transported to the machine? How will people get to and from machine, and will they interface with internal transport routes? What restrictions may be imposed by the size of the building, height, pillars, gangways, etc.? What working space will be available for operatives, and is it adequate? What is the likely impact on noise levels in the area, considering adjacent equipment? Where are the nearest connection points for services, electricity, gas, air, water, etc., and what impact could they have on other activities? Is the environment suitable, and will there be adequate heat, light and ventilation, etc.? Are the required electric, pneumatic, hydraulic connections available for the new machine in the designated work cell area? What civil engineering will be necessary for the work cell area? Can the available electric circuit take the additional electric load required for the new machine? How will the equipment be moved into place? Does the workstation have scrap counter? Does the workstation have an adequate space for enter and escape? Does the workstation have all the requirements for 6S? Does the workstation include ergonomics best practices? 4. Lifting heavy loads, carrying bulky loads or loads far away from the body, frequent lifting. Bending the trunk, as when picking items up off the floor or when reaching into a bin. Twisting the trunk, static loading, such as holding or carrying objects for long periods of time. Pushing or pulling. Does the workstation have adequate lighting? Does the assembly tool need a yoke mistake proofing for placing the part and components in the correct orientation for assembly? This is the proposed manual assembly tool I received from the appointed supplier. I approved this 3D design after I had the required design review with the supplier. I gave the supplier approval with comments for correct and proceed. I listed the open issues for the correct and proceed in the meeting memorandum I sent to the supplier in an email soon after I arrived at my office. Yes, I have a design review approval sheet. I will introduce it to you later in this video. I originally sent the request for quote to 3 suppliers. I gave the job to the best supplier for the job after he accepted my target cost for the tool. These are the standard components for our manual tools. The following are work instructions I received with the manual tool. Step number 1: place the fixture on the workstation. See the work cell layout. Step number 2: visually inspect the molded part. Look for molding defects and damage details. See the good and bad samples boundary your manager provided with the assembly instructions. Step number 3: place the bracket on the fixture. Step number 4: visually inspect the retainer clip and place the clip on the insertion tool as shown in this picture. Step number 5: align the insertion tool to the key slot as shown in the picture and push the retainer clip in position until you hear and feel a click. This will tell you the clip is in the correct position. Step number 6: repeat steps 4 and 5 for the second clip. Step number 7: visually inspect the part after assembly. This picture shows a good assembly because the clip is pushed to the required position. The part must have 2 clips assembled correctly. A missing clip is not acceptable. After you have assembled both clips, you should do a shake test. Make sure clips will not fall off the bracket during and after the shake test. Step number 8: place the finished assemblies in the C tote. Place 30 assemblies in the tote and place 12 full totes on the pallet. Must use the returnable C tote with the returnable C pallet. Workmanship. Tool construction to a standard that ensures durability and stability for continued use in a plant environment, for the life of the part, and must include a warranty of materials and workmanship as defined and agreed upon during the quotation stage. The bill of material must include dates for start and end of warranty for each component, and must include the warranty definition for each component. Responsibility. The tool supplier is 100% responsible for the fit and function of assembly tool, and the Amer project team will not approve the payments until after the tool is 100% production ready and past the run at rate process as defined by the OEM. If deviate from purchase order, Amer purchasing department will be immediately informed of any differences. Assembly tools shall not be built or modified to a level beyond which a written purchase order exists and defines. Design approval and waiver. Design approval shall not constitute a waiver or guarantee of responsibility for any tool purchased by Amer. An approved tool design does not constitute a certified or an approved tool. Design reviews. All tools design shall be submitted to Amer tooling engineer for final review and recommendations at a design conference or at designated meeting. Documentation and drawings. All designs are the property of Amer. Detailed tool designs are required. Each submission of the tool designs to be accompanied with STEP, PDF and DWG files. A final copy of the tool designs and drawings to be supplied on or before you ship the tool to Amer. These are the required formats: native 3D and 2D files, STEP, PDF, and DWG files. 2D full design is not mandatory unless otherwise specified. When a 2D drawing for a manual tool is required, a copy of a PDF, native, and DWG files shall be submitted. The bill of material for the tool must be detailed as required by Amer tooling standards. Alternatives. As a part of this quotation, you are encouraged to offer alternative tool designs to achieve better assembly process, cycle time reductions, and for quality assurance to our specified request, especially those that include off-the-shelf components or industry standards, but still fulfill the required function. Tool design, and purchased components. A. The responsible tooling engineer, representative of Amer, shall review the tool designs, providing recommendations, comments as required. B. All tool design shall be submitted to Amer for review and recommendation at a design conference or at designated meeting. C. Supplier shall not buy tool steel or components until after the tool design is approved by the Amer tool engineer. D. It is the supplier responsibility to record all changes to the design during the mold construction and to subsequently update the original design tracings. E. The supplier has the final responsibility for tool modifications or corrections to ensure that final operation and production produces part to print. Bill of material is required and must define the warranty for each component as shown below. Timeline and open issues. The tool supplier must submit a tool timing chart, showing detailed timing for each milestone event of the design and build process, within 1 week of receipt of the purchase order. This timing chart must be updated and submitted to the Amer tool engineer with an open issue document, weekly, and must contain at a minimum, start date, duration, completion date, name of the responsible person for each task, date received purchase order, tool kick-off meeting, tool design concept review, tool design review, final tool design review and approval, the drop-dead date for purchasing materials and standard components, tool construction, receive material from Amer to your facility for the first tryout, date for the first tryout, and the timeline must include timing for 3 tuning loop and the tool run-off. The weekly progress report timelines must include the open issues document, pictures of the tool and components. A weekly conference call meeting for the weekly progress report and open issues is required. Supervision and inspection. The Amer tool engineer and his team reserves the right to visit the tool source at reasonable times and frequencies to inspect the tool and/or tool design during design and build phases. Review status of the tool and progress made towards completion. Ensure compliance with the requirements of this document. Tool tryouts. All changes must be authorized in writing by the responsible Amer tool engineer. Warranty requirements. Start date and period of warranty. Definition of supplied items included. Defined where parts excluded, providing defined lifetime reached. Labor included in warranty and for how long. Shipping and handling costs under warranty. Non-wear parts replaced to have separate warranty period of fixed price for spare and warranty parts. Spare parts, service, and software requirements. Supplier guarantee of availability of spare parts and accessories for specified number of years. Guarantee of availability of expert advice for the period as defined above. Customer service personnel supplied must speak the English and the local language. For example, English for the USA and Spanish for Mexico. If the manual assembly tool needs a manual press, must use Schmidt manual press suitable for the required force and size. For example, Schmidt manual press, NR6RX1 rock and pinion press with the needed optional accessories as shown below. Introduction. In addition to the above noted requirements, the following requirements are for a fully automatic and semi-automatic assembly machines. 1. The included specifications are intended to be a guide for production equipment suppliers. Information contained within these specifications contains quoting, design, build and run-off requirements for equipment to be purchased by Amer. 2. It is expected that all vendors will adhere to these specifications in their entirety. 3. All machinery, equipment supplied to Amer must comply with all current applicable regulations, including the following industry standards. Occupational Health and Safety Act Michigan. General Operator and Maintenance Safety. Operator Ergonomics. Noise Control. Electrical Controls. American National Standard. National Fire Protection Association Nfpa 96, Electrical Standard for Industrial Machinery. Documentation and drawings. 1. Each submission of tool designs to be accompanied with native 3D and 2D files, STP files of the 3D data, DWG files of the 2D drawings, and PDF files of the 2D drawings. A copy of all final files are required to be supplied on or before the run-off on Amer's floor. Machine layout. 2. Showing size and general outline, location of motors, hydraulic units, fixtures, chip removal, panel access door swings, operator position, foundation requirements, pits, leveling screws, anchor bolts, and location of service connections. For automatic machines, part entry and exit points must be indicated, direction of part flow, and bottom of part elevation above floor must be shown. In addition, for plant layout purposes, a plan view shall be prepared showing size and general outline of machine, relative location of electrical panels, hydraulic units, coolant tanks, etc. Indicate as much detail from the machine layouts as practical. Tool and fixture layout. 3. Shall show all cutting tools, slides, adjustments and replacement means, feeds, speeds, cycle time and motion chart of slides and or head, if applicable. Fixture layout will show means of clamping, locating, and setup for multiple part use, if applicable. Perishable tools. 4. Drawings of all special perishable tools shall be furnished, including tools altered from standard. A reproducible drawing listing all standard tools shall be furnished and listed either in parts column of tool layout or on a separate sheet. Also, setup dimensions must be included. Control drawings such as 5. Electrical, hydraulic, pneumatic, and lube system. 6. System interconnection diagrams. Drawing shall show relative location and identifies all e-stops, fence switches, perimeter guard switches, electrical boxes, and the cable and conduit runs. All cable and conduit runs should be labeled. Diagram shall also include bill of materials, in table format located upper right-hand corner of drawing, for all devices shown on the diagram, tool and fixture wire and piping diagrams. 7. Drawing shall show in schematic symbol format all the wiring, piping, and system settings for all e-stops, fence switches, perimeter guard switches, valves, filters, regulators, flow switches, cylinders, proximity switches, limit switches, etc. In relative position to the equipment the assembly tool is intended to electrically communicate with, show where the connections are located on the new and the current machine. Also, the electrical identification of the new assembly tool must match the electrical identification shown on the available press or machine, point out the connections and switches to a physical location on both machines. The current and new machine's schematic must correlate to each other. Diagram shall also include bill of materials, in table format located in the upper right-hand corner of drawing, for all devices shown on the diagram. 8 hydraulic wire and piping diagrams. Drawing shall show in schematic symbol format all the wiring, piping, and system settings for the hydraulic system. Diagram shall also include bill of materials, in table format located in the upper right-hand corner of drawing, for all devices shown on the diagram. 9 chemical wire and piping diagrams. Drawing shall show in schematic symbol format all the wiring, piping, and system settings for the chemical system. Diagram shall also include bill of materials, in table format located on the upper right-hand corner of drawing, for all devices shown on the diagram. 10 conduit schedules and pin charts. Drawing shall show the conductor numbers or pin numbers for all cable and conduits runs. Diagram shall also include bill of materials, in table format located in the upper right-hand corner of drawing, for all devices shown on the diagram. 11 communication network drawings. Drawing shall show all remote I/O, data highway plus, DH plus, data highway, device net, etc. connections and terminations. Each connection shall show pin number, wire color code, terminator type, and value. Diagram shall also include bill of materials, in table format located in the upper right-hand corner of drawing, for all devices shown on the diagram. 12 sequence of operations. The tool sequence of operation drawing shall be in chart format and include the following information. Sequence step number, description of sequence step, valve or device energized address, switch made address, and cycle time of the step. 13 magnetics. Drawing shall show all 480 VAC, 120 VAC, 24 VDC magnetic circuits. I/O drawings. Drawing shall show all inputs, outputs, dip switch settings definition, channel configuration, etc. 14 interface drawings. Drawing shall show all hardware, dip switch settings, setting definition, and memory maps for interface between system and robots, drives, panel views, RS view, device net, etc. 15 panel layouts. Drawing shall show, to scale, panel layouts and push button layouts. 16 software documentation. Documentation shall include 3 printed copies and a disk copy for each of PLC SLC program logic with cross-reference in RS Logix format. Panel view application file in panel builder format. RS view application file. Device net application file. Robot programs, disk copy only. Drives configuration file. Any programmable 17 manuals. Shall all be original publications, in English, for all purchased subsystems and components. 18 documentation distribution. Upon shipment of equipment 1 set shall be supplied to the engineering department of the plant where the equipment will be located. 19 If required, foundation drawings must be forwarded to Amer, at least 6 weeks prior to shipment date. 20 Approval drawings. 21 2 sets of prints for approval drawings must be submitted for approval before construction is begun. Machine, tool, and fixture layouts and control system drawings are required. Approval of drawings does not relieve the vendor of responsibility for satisfactory performance of the equipment. Drawing numbers will be assigned with approval of drawings. 22 Approval drawings must have final approval before equipment is built with all engineering changes completed. 23 Machine drawing specifications. Assembly drawings E-size, 36, x 48 to 72 lg. 0.00 starts at floor for elevation and 0.000-0.000 center line of piece part. Minimum of 2 views, front elevation and plan view preferred. 1/4 to 1 inch plan views of complete system. Show electrical enclosures and guarding. Station layouts viewed from operator's position. Assembly drawings start with sheet number 2. 24 stock list on D sizes sheet, sheet number 1. Manufactured details on right side numbered from bottom to top, part name not stock size. Assembly drawings and stock list to be listed on stock list before manufactured details. Purchased details to use $, appear on right side of stock list and numbered from bottom to top. Altered details to be called out as manufactured detail. 25 detail balloons. 5 8-inch diameter split with sheet number in lower half and detail number in upper half of balloon. 1/2 inch diameter balloon with detail number only on detail sheets. Purchased details to have $sign preceding number. Manufactured details to start at detail number 1 and purchased detail to start at detail number $1. 26 detail drawings. Standard English dimensions. Request for metric or both English and metric print dimensioning will be specified in quote documentation if required. Datum line dimensioned. Where possible, put 0.00 on critical surfaces. Details drawn on D size sheet, maximum of 4 details per sheet. Large weldments or plates may be drawn on E size sheets, with no more than 1 detail per sheet. Use decimals for hole diameter call out and dimensions. Details to have detail number, part name, and quantity required, material, and hardness where applicable, and finish. Weldments to have stock called out with letter, quantity received, stock size and material. Example, A, 2, required 1/2 inch by 6 inch by 3 inch, 1020 hot roll steel. 27 timing charts. All automatic and semi-automatic stations to have timing chart. Sequence, actuator, and time for motion should appear on chart. Must have counter and detection sensors. 28 tolerances. Dowels ±5 10,000ths inch. Screws ±5 thousandths inch. Drawings to have decal or stamp with tolerances as follows. 4 place dimension. ±5 10,000ths inch. 3 place dimension. ±5 thousandths inch. 2 place dimension. ±100th. Angles ±1/2 degree. Unless otherwise specified. 29 control drawings. Size A, 8.5 inch by 11 inch. Utilizing vendor's title block with job number, address, and phone number. Drawing file name shall appear on all drawings in lower left-hand corner going 90 degrees up the side of the drawing outside of the title block. All device names shall include I/O address. Electrical drawings shall use ANSI standard AutoCAD symbols for electrical, pneumatic, and hydraulic devices. Each and every device, fuses, relays, relay contacts, switches, valves, etc. shall be annotated as shown in this chart. 30 machine manuals. 3 sets of machine manuals shall be furnished with each machine. Manuals will be hardcover bound, loose leaf type, with both cover and spine labels to identify machine number, machine description, and manufacturer. Manuals will be delivered to the engineering department at the production facility where the equipment will be located. Manuals are expected to be delivered with the equipment. Manuals will contain, but are not limited to, the following information. Operating instructions. Setup instructions. Preventative maintenance procedures. Equipment troubleshooting guidelines. Recommended spare parts list with cost availability. Catalogs, user manuals on major machine components. Electrical, pneumatic, hydraulic schematic diagrams, can be reduced size copies. PLC program logic and cross-reference. 31 frame color painted RAL 5002. Ultramarine blue gloss. Do not paint aluminum frames. 32 assembly tool and fixture identification. The Amer team will provide the tag information for each machine. Shall be identified with a permanently attached metal tag reflecting Amer project number, Amer part number, Part names. Program platform. Less finish part number. Assembly part number. OEM 3D CAD file level and name. OEM 2D drawing level and name. Final certificate date if applicable. Property of VTAM number or asset numbers. OEM platform, part number, and part name. The followings are Amer requirements for commercial off-the-shelf components. 1. Electrical. PLCs Allen Bradley PLC 540, SLC 505. Proximity switches effector, 3-pin, BALUF, 3-pin. Preferred suppliers, Allen Bradley, Banner. Transducers BALUF, Allen Bradley. Light curtain slows Lumiflex, Banner, SICK. Relays Allen Bradley, Siemens, Omron. Push buttons Allen Bradley 800T. Motors, Alder. Power supplies, Sola International Power. Fuses standard cartridge. Switches Allen Bradley, Omron, Siemens. Variable frequency drive Allen Bradley 1336 and Balder. 2. Hydraulic. Cylinders Hydroline, Parker. Valves Vickers, Bosch, Parker, Sun. Filters Schroeder Parker. Fittings Parker. Seals Parker. Pumps Bosch. Temperature. Heater elements Wutlow. Heat exchangers Thermal transfer. Vacuum. Pumps Becker. Pumps, small, PIAB. Suction cups PIAB. Valves Harrion. Equipment suppliers. Water jet cells Robotic Production Technologies Flow International. Heater chillers Advantage Engineering. Hydraulic units Robeck Fluid Power Pabco Fluid Power. Robots Fanuc. Metering systems Kraus Maffei, Canon Knows, Advanced Controls and Engineering Conal Engineering. Air compressors Kaiser Compressors IR, Pneumatic. Cylinders Parker Festo. Valves Parker, Pneumatic, Mac. Filters and regulators Watts, Pneumatic, Wilkerson, Pneumatics. Chemical. Filters Norman. Mick heads Kraus Maffei, L Style 812, Advanced Controls and Engineering. Conal. Spray guns Devilbus. Pumps Graco, Aero. Mechanical. Bearings Timken, Thompson, RHP, SKF, NTK, Browning. Gears and sprockets Martin. Chains Martin. Eurodrive, motors and gears, so Eurodrive. Couplings Daco Talloy, Lovejoy. The following are for the assembly fixture specifications. Frame construction. The preferred frame construction is 802 extruded aluminum. The molded part nesting fixture must have full contact with the molded part where necessary for countermeasures backup. The contoured nesting fixture must have locators for repeatable positioning the molded part on the assembly fixture. The assembly fixture must use 4-way and 2-way locators for the molded part positioning. If the molded part warpage is interfering with the required position for assembly, the center supports can be minimized, or if necessary, use pour casting for making the nest. We recommend Model Pro polyurethane casting resin, instead of CNC cut the nest. The base frame shall have minimum of 4 tooling balls. 1 on each side, 1 front 1, rear. The working height shall be within ergonomic standards. The assembly fixtures shall be manually adjustable ± 6 inches from nominal height. The adjustments will be in 1-inch increments. The assembly fixture shall have removable 6 casters, swivel. The assembly fixture shall have 4 duplex 110 vac, 15 amps outlets. The outlets shall be independent of the control panel. 1 outlet shall be positioned on each side of the fixture. Swing arms. All swing arms for component placements shall have a minimum of 2 tooling balls on each arm. All swing arms that exceed 5 pounds shall have a counterbalance, air cylinders with flow controls. The component best will be full contour. The swing arms shall hold the components with vacuum. The swing arms shall have part presence sensors for the component. The swing arms shall be sensed in the open and closed position. The swing arm shall be adjustable to locate the component directly to the molded part. The swing arms shall lock in place with an adjustable timer. The swing arms will have AB-style lighting to communicate to the operator's swing arm cycle. The swing arm shall open to a near horizontal position for hot melt glue application. The swing arm shall be adjustable for component placement and lockdown. The swing arm shall have cushion stops in the open position. The swing arm shall be guarded for pinch points approved by Amer. Monitors. Each fixture shall have a B panel view 1000 monitor. The monitor shall have multiple screens for setup, maintenance, manual run mode, production, error reporting. The font size shall be readable from 8 to 10 feet away. Typical items displayed are serial numbers, part numbers, etc. The details of the displays will be finalized at the design reviews. The monitors are to be mounted, fixed pedestal, on a flex cable that is 10 foot long and will be finalized at the design reviews. Controls. The PLC controller shall be Allen Bradley 505. The control system shall have a 50% spare I/O. The control cabinet shall be sized for 25% increase of I/O above the spare I/O. All connections to and from control cabinet shall be twist lock bulkhead connectors. All communications cabling and voltage wiring shall be in separate cable trays. The fixture control shall be mounted on the side of the fixtures. Controls to be broken into two cabinets left and right, and the devices will be broken out to left and right side as well. Air valves and controls. All air valves, air lines, and controls shall be sized for 100% over capacity. All air valves and manifolds shall be located on the side of the fixtures for unobstructed access. The valve packs need to have a plexiglass cover to keep the operators from bumping or hitting the valves. Labeling of the air valves and manifolds shall be of a size that is readable from 36 inches away. Torque guns and controllers. The Torx guns and controllers will be supplied by Amer Integrated Systems. Amer shall be responsible for the torque gun programming and parameters setup. The supplier of the assembly fixtures shall provide controller mounting on the assembly fixture, holster for torque gun, PLC error-proofing programming for established parameters. PLC programming subtract 1 from the batch count when gun is put in reverse. E-stops and locations. Each assembly fixture shall have 2 E-stops. 1 on control panel. 1 on each fixture on the underside of the plate or in an area where it cannot be hit by mistake. Hot melt glue equipment. The hot melt glue equipment and hot melt glue shall be supplied by Amer Integrated Systems. The fixture programming must include part presence to enable pump to turn on. The fixture programming must include a timer to shut off pump at X amount of time that will be decided by Amer. Fixtures need to have holsters for the glue guns. Amer Engineering will determine the location of the holsters during the design reviews. Laser lights. Should visual aid be required for components locations or routing be required for components such as NVH pads, washer hose, wire harnesses and/or brackets, we will use laser lights. Laser lights shall be placed under the molded part assuming that the beam will shine through the material. If the molded part material does not allow the laser beam light to show through, then laser will have to be mounted overhead. Ergonomics, guarding, and safety features. All ergonomic, guarding, and safety features must meet OSHA standards and requirements. The fixture base plate needs to allow the operators to get as close as possible to the edge of the part. Swing arms needs be small as possible as well as low profile to allow the operator to get as close to the part as possible. Assembly tools built for Mexico, if applicable. Assembly tools going to Mexico must have Mexico recognized safety and sustainability standards for the machine and components. Mexico code inspection and certification are required. It is the responsibility of the fixture builder to meet codes and get certifications prior to shipping. The following are for general safety requirements. Safety representative check. Amer safety representative, prior to delivery, shall check machinery and equipment supplied to Amer. The equipment shall be operated with a full load of parts to check for regulatory acceptable, guarding, controls, control of hazardous energy, operator ergonomics, noise levels and ventilation. Machine guarding. One or more methods of machine guarding shall be provided to protect the operator and other employees in the machine area from hazards such as those created by pinch points, point of operation, rotating parts, and flying chips. All guards shall be affixed to the machine where possible and secured elsewhere if for any reason attachment to the machine is not possible, or if the guarding is an access point to the machine. The guard shall be electrically interlocked to disrupt all machine functions if it is not in place. The guard shall be such that it does not offer an accident hazard itself. Point of operation guards shall prevent entry of hands or any other body parts into the point of operation by reaching through, over, under, or around the guard. The guard shall conform to the maximum permissible opening requirements set OSHA by 29 CFR 1910.217 subpart O. It shall, in itself, create no pinch point or shear point between the guard and moving machine parts. It shall utilize fasteners requiring tools to remove, to minimize the possibility of misuse or removal. Point of operation devices includes gates and presence sensing device. Amer preference for point of operation devices are presence sensing devices, i.e. light curtains or mats. Any deviation in design must be approved by the Amer Safety Department. Presence sensing device, PSD, shall protect the operator by preventing or stopping the normal operations of the machine if any body part is placed into the point of operation. The supplier will provide the formula and calculations used to size and place the PSD. A PSD shall not be used as a tripping means to initiate machine motion. A PSD shall be constructed so that failure within the PSD system does not prevent the normal stopping action from being applied to the machine but does prevent the initiation of a successive motion until the failure is corrected. The PSD or machine shall indicate the failure. Machine controls. A mechanical or electrical power control shall be provided on each machine to make it possible for the operator to cut off the power from each machine without leaving his or her position at the point of operation. All emergency stop buttons shall be maintained push-pull type, red in color, and all remotely located operator stations shall be equipped with their own device. After power failures, provisions shall be made to prevent machines from automatically restarting upon restoration of power. In the event that a guard, gate, or PSD cannot protect a point of operation, two-hand controls must be used for each operator. The two-hand controls shall be the anti-tie-down type and located in a manner to prevent bridging between the two controls. Operation shall require manual activation of both controls until a point is reached in the cycle where the operator cannot remove his or her hands and place them within the point of operation. If machine cycle repeating would cause an injury, an anti-repeat device shall be incorporated into the control system. Control of hazardous energy. The supplier shall supply Amer with information on all calculations used for sizing and placement of the PSD, as well as all safety precautions that should be taken for the safe operation of the equipment, including zero state, during maintenance and service of the equipment. Energy sources that must be considered are electrical, pneumatic, hydraulic, gravity momentum and stored mechanical energy. Special energy such as steam, water, chemical and thermal. All energy sources shall be equipped with a lockable energy isolating device. Energy isolating devices shall be designed to accept a lockout in accordance with Occupational Health and Safety Act and the Michigan Occupational Health and Safety Act. The supplier shall submit to Amer a lockout placard layout and procedure, detailing each energy source, energy isolating devices, method of disconnect, release of stored energy, and lockout verification. The placard shall be located on the main electrical panel or the main energy source. Each energy isolating device shall be clearly labeled to match placard. On vertical or the goal of this specification is the purchase of equipment by Amer, which incorporates feasible sound level controls. Equipment operating in normal automatic mode with parts shall not exceed 80 dBA. A sound level meter or dosimeter conforming, as a minimum, to the requirements of the American National Standards Institute, ANSI, Specification for Sound Level Meters, S1.4-1983, Type S2A of ANSI S1.25-1991 Specification for Personal Noise Dosimeters, should determine the sound pressure level. The measurement device should be set to use a scale with a slow response. A measurement must be taken at operator's hearing zone, also at the highest sound producing device if above the acceptance level. Measurements must be taken with equipment under no load and under full load production operating conditions. Examples of sound generating equipment: pneumatic tools, electric motors, transformers, air moving devices, pressure filling devices, metal shearing, hydraulic pump wine, robotic water jet cutting. Sound leveling methods such as baffling, insulation, deadening, etc. must be built into the machine design rather than retrofitted after building. Note: waiver conditions: if equipment exceeds the applicable sound limit or the best achievable sound limit quoted and acceptable by Amer, the supplier shall request written permission to ship the equipment. The supplier must submit in writing, upon request to ship, detailing of the feasible engineering controls currently designed into and or installed on the equipment. Shipping the equipment does not release the supplier from the responsibility to meet the required sound limitations. Written authorization to ship machines or equipment exceeding the Amer sound level specification limit must be obtained from the authorized plant representative, prior to shipment. Ventilation. Amer is dedicated to maintaining a clean, uncontaminated atmospheric industrial work environment. However, the use of hazardous and non-hazardous materials that result in the creation of particulate, gases, vapors and/or mists are common in the modern workplace. The use of a correctly designed local exhaust system greatly reduces the amount of the aforementioned atmospheric contaminants. All ventilation systems must be designed using an approved American Conference of Governmental Industrial Hygienist method. The following are for pneumatic specifications. Operating pressures. Pneumatic systems shall be designed to operate within a pressure range of 60 to 70 pounds per square inch gauge. Pressure control required at each valve. Pressure gauge required at each valve. Safety shut-off valves. Only one source of air supply shall be used for each piece of equipment. All pneumatic supply lines shall contain a three-way shut-off valve with provisions for locking it in the off position. This valve shall comply with OSHA Standard 29 CFR 1910.147 for general safety. By pushing the handle inward, you block inline pressure and relieve downline system pressure after locking with a padlock, which ensures safety by preventing accidental actuation of cylinders. All system piping shall be arranged to drain pressure from all prime movers when the main shut-off is in the closed or off position. Filters. Airline filters shall be with replaceable shatterproof transparent bowl and automatic drain. Regulators. Airline regulators shall be relieving type with gauge. Use filter regulator combination assembly wherever possible in order to reduce piping. Lubricators. Airline lubricators shall be with replaceable shatterproof bowl. Directional control valves. Pneumatic direction control valves should be manifold, or panel mounted where piping can be simplified. All valves shall have indicator lights. Plug-in style mandatory. Valves shall be spring center or spring return types. Detent type valve requires approval. Mufflers. All air exhausts shall be equipped with mufflers. Cylinders. Cylinders shall have interchangeable mounting dimensions and shall have adjustable cushions on both ends. Air receivers. Air receivers shall be constructed per ASME code. Vendor shall provide a copy of ASME form manufacturer's data report for uniform pressure vessels, complete and signed by licensed ASME inspector. Marking of components. All pneumatic components shall be labeled for identification by means of a stamped metal plate or engraved plastic tags mounted adjacent to, but not on the device and held by some mechanical means. Adhesive tags are not acceptable. Identification shall match component identification shown on pneumatic diagram. Pressure and pressure controls. Hydraulic systems shall be designed to operate within a maximum pressure of 3000 psi, when applicable. Hydraulic equipment shall be designed to withstand the maximum pressure to which they may be subjected plus 50% overrating. All pressure controls shall be marked to indicate minimum and maximum pressures by means of stamped metal or engraved plastic plates held by mechanical means adjacent to the control. Adhesive tags are not acceptable. Pumps. Pumps shall not be mounted inside the oil reservoir. Flexible couplings shall be used between pump and motor. Where pumps are operated in parallel, valves shall be installed to permit removal of one pump while other pumps remain in operation. A detachable safety guard shall be fastened over the coupling and shafts. Direction of rotation of each pump shall be clearly indicated on the pump by a metal identification plate. Printed or decal arrows are not acceptable. Solenoids. Quick disconnect type with indicator lights. Standard wet core. All pilot and directional valves shall be spring center or spring return types. Detent type valves require approval. Fluids. All fluids, power components, seals, external paint, etc. shall be compatible with the fluid to be used. Each hydraulic reservoir shall have metal tag affixed near reservoir fill spout to identify the appropriate hydraulic fluid. List of inventoried hydraulic fluids. Preservoirs. Filler holes shall have a strainer for straining the fluid when filling. Reservoir shall be provided with markings to continuously show high and low levels of fluids with the pump running and high level with the pump stopped. Ample and readily accessible means shall be provided for cleaning the reservoir completely. Temperature gauges required on all tanks. Filters, strainers, and flow meters. Replaceable, cartridge type, non-absorptive, 30 micron absolute, full flow, bypass when cartridge is plugged. Filters shall be installed on the pressure side of the pump for all systems operating at 500 psig or less. Systems operating at pressures over 500 psig may incorporate the filter in the return line. Hydraulic systems utilizing solenoid-actuated hydraulic valves shall incorporate an additional 10 micron minimum absolute telltale hydraulic filter to further protect the valves. Filters shall have an external indicator to show degree of contamination. A simple gauge recording pressure drop across the filter is not acceptable. Filters and strainers shall be installed so that it will not be necessary to drain the reservoir or disturb the piping for servicing. Filter identification tag shall include cartridge number. Pump suction, risers shall include strainer of appropriate size, at least 74 micron strainer. Marking of devices. All devices shall be identified by means of a stamped metal plate mounted adjacent to, but not on the device and held by some mechanical means. Adhesive tags are not acceptable. Identification shall match component identification shown on hydraulic diagram. Hydraulic piping and tubing. Copper tubing shall not be used for conveying hydraulic fluids. Tubing shall conform to the following specifications. Hydraulic piping and tubing shall not be bundled. It shall be laid in parallel runs and securely fastened to the machine. Piping and tubing shall not be routed where it can serve as a step for personnel operating or repairing the machine. Cast iron clamps and one-hole pipe straps are not acceptable. Heating and cooling water lines shall be copper, galvanized, PVC or stainless steel. Steel tubing or black pipe shall not be used. Diagrams, see design section. Maximum size of sheet shall be 24 x 36. The hydraulic schematic diagram shall show relative location of limit switches, pressure switches, etc., coded to electrical schematic. The hydraulic schematic diagram shall show complete hydraulic parts list giving quantity, model, and manufacturer coded to the electrical schematic drawing. Any standard component that has been modified in any way must be listed and the changes described. Gauges. All pressure gauges shall be liquid filled with isolators. The following is for lubrication specifications. Lubrication gauges. Gauges located 4 feet or less from the floor level shall be flush mounted to or recessed within reservoir walls. Prevention of over-lubrication. Positive means shall be used to prevent damage caused by over-lubrication. Automatic lubrication systems. Automatic lubrication systems shall be designed to operate only during the operation of the machine. Automatic lubrication systems shall have a high-low adjustable pressure switch to disable any further cycling of the machine, if a high or low condition occurs. Setting to be specified by means of a stamped metal plate adjacent to, not on device and held by mechanical means. Adhesive tags are not acceptable. Minor fault shutdown of machine if low level is achieved on lubricator reservoir is required. Manual lubrication points. Lines from overhead or inaccessible points will be run to ground level where they are accessible. The following is for electrical specifications. Standards. Design and installation of electrical components shall conform to the latest National Electrical Code, Michigan OSHA, and National Machine Tool Builders Association standards. All electronic equipment shall conform to the latest electronic standards for industrial equipment. The equipment is to be housed in NEMA 12, or better enclosures. Enclosures shall be sized to not require cooling. All wiring shall be machine tool grade, heat, and oil resistant. The wire colors shall be as follows: black 120 VAC, green earth ground, red 120 VAC. Blue DC and DC components, yellow remote power, white 120 VAC common, white blue stripe 24 VDC common. Amer must approve any deviation from the standard or the above standards. Utilities power. Amer will supply 120 volts, 240 volts, or 480 volts 3-phase, Y, at the amperage specified for each piece of equipment. Amer has a 3-conductor bus system, no neutral. Any deviation requires approval. Motors are to meet National Electrical Code and UL recognition or equivalent. All motors are to be single shaft, foot-mounted and totally enclosed. Motors are to be fan-cooled. Flange-mounted integral brakes, special shaft lengths or other special motors require approval. Motors, 1/2 horsepower and up, motor circuit. Each motor will have its own motor starter, instantaneous time delay current protection and time delay overload protection. Motor starters shall be size 0 or greater. Shall operate on 480 VAC 3-phase 60 Hz. Motors shall be clearly set forth in the quotation with the rating in volts, amperes, horsepower, frame, RPM, and compliance with Amer specifications. Any motors other than 480 VAC 3-phase 60 CY or 120 VAC 1-phase 60 CY shall require approval. Power factor correction. Power factor correction shall be included on all equipment rated 10 horsepower and above. Size, make and rating to be stated in quotation if known. Enclosure to be dust-proof. Control enclosure. Disconnect switch shall be installed so that minimum bending radius for line leads brought in from side will comply with that shown in National Electrical Code Table 373-6, A. Single or odd number of doors will require a flange-mounted disconnect. All I/O racks shall be clearly marked, and wires labeled with corresponding PLC address. All discrete input and outputs shall be wired to a terminal strip, control panel and devices. The bottom of the lowest panel-mounted control device shall not be less than 18 inch above the operating floor line or machine base plate. All circuits and devices greater than 120 volts shall be safe touch. Safe touch is defined as the ability to work on or near device without being exposed to electrical hazard. Examples of safe touch: plastic covers with probe access over 480 fuses and distribution blocks, terminals with recessed contacts and screws, etc. All fuses and circuit breakers shall be labeled and mounted on backplate where possible. Where not mounted on backplate, fuses must be guarded. Each fuse shall have its own discrete input to the PLC for diagnostic. E-stop buttons and all devices in the MCR circuit shall have their own input for diagnostic purposes. Cable trays are to be the slotted type, with no covers longer than 36 inches. All control circuits shall be 24 VDC unless otherwise approved. All pilot and indicator lights shall be oil-tight. Push buttons and selector switches shall be oil-tight and arranged on operator panel in order, left to right, to follow the manual operating sequence. There shall be a push button or a selector switch to control every machine function in both directions. Ground detector pilot lights must be used on all machines having control transformers of 500 VA or larger. All solenoids, devices, and relays will have 24 VDC coils with freewheeling diodes, rated at 600 volts or higher. Each device will be wired to its own PLC output. Solenoids shall be fused with individual indicating devices besides. Motor starters shall have at least one NO interlock contact for use in the control circuit. All relays and other devices in the control panel shall be arranged in consecutive numerical order. A permanent nameplate held by some mechanical means, adjacent to, but not on, the device shall identify each device. This nameplate shall be on the panel and visible when panel is completely wired. Control panel shall have terminal blocks numbered in numerical order and containing test points for all machine-mounted devices. Terminal block mounting channel shall have 1 1/2 inch metal spacers behind them for ease of wiring and sufficient space on both sides to permit easy installation and checking of wires. All wires in the panel shall be numbered on both ends to conform to schematic diagram. 10% spare wires shall be provided. Wire numbers and letters shall be of 7/8 vinyl cloth labels or equivalent. Panel shall include an external PLC programming connector and 115 VAC programming power duplex plugs for access without opening the cabinet. Location pre-approved by Amer. Solid-state devices and programmable controllers. Programmable controllers and solid-state devices are to be used. PLCs shall be Allen Bradley SLC 5/05 or better, with Ethernet connection available. PLCs remain powered up with the loss of control power. All screens shall be of network compatible. Programmable controllers shall have a minimum of 15% spare, unused, inputs, outputs, and memory space. A 115 VAC duplex receptacle shall be mounted and wired in control panel for use of programmable controller auxiliary equipment. Programmable controller logic shall be supplied to Amer on external hard drives and a minimum of one printed copy in RS Logix 500 for SLC. All non-industrial electronic equipment to be powered on a separate solar transformer. Not to exceed 80% loading. Each PLC output card shall be separately fused on its power input. Each PLC will have a modem for remote troubleshooting. Reversing starters are to be electrically and mechanically interlocked and require approval. All machine position indication devices will be solely wired to dedicated PLC inputs. Serial communication standard. Communications will use a BRIO if possible. A map, to be included in the documentation, of the communication wiring will detail the location, address, baud rate and termination of all remote devices. The RS-232 standard will be used for other miscellaneous serial communication if required. Machine-mounted devices, if required. The machine shall have an operator's diagnostic panel mounted where it is easily visible to the operator. Panel lamps or display are to show activity of limit switches and machine function status. Optional, panel shall show a graphic picture layout of machine and physical approximation of location of limit switches. All servo systems require approval. Motion control, to achieve position, will use an encoder. Position will be displayed on the operator panel. All machine-mounted devices shall be numbered to correspond to schematic diagram by means of a permanent engraved plate adjacent to, not on the device, and held by mechanical means. Adhesive tags are not acceptable. When possible, limit switches, proximity switches and other machine-mounted devices shall be a quick disconnect design, oil-tight, and labeled by means of an engraved plate which is traceable to the appropriate wiring diagram for title and I/O number. Proximity switches are preferred. PX and limit switches shall have only one normally open contact. Other contact arrangements require approval. A limit or proximity switch shall be used to indicate full travel at both ends on all mechanical functions. Timers or cylinder pressure switches are an unacceptable means of indicating or assuming full movements. Exception: a pressure switch can be used in addition to limit or proximity switches to indicate required force needed for a particular function. Photoelectric devices shall include an indicator light to indicate correct alignment and actuation. Proximity switches shall have a visible indicator on the prox or as part of the connector. Diagrams and documentation, also see design section. A reproducible schematic diagram shall be supplied and be so drawn that wire numbers are in numerical order or per PLC I/O numbers. Relays are in numerical order, MS1, CR2, state route 1, etc., and may not be numbered by any other code. Proximity switches, PX1, PX2, and limit switches, LS1, LS2, etc., are in numerical order with a chart showing contact locations, when operated, and by what means. All relay contact usages are to be fully cross-referenced. Title block shall identify machine by name and serial number, builder, and job number. Views of the machine shall show by schematic symbol the approximate location of limit switches, pressure switches, control panel, motors, etc. A complete parts list is given showing quantity, manufacturer, and catalog number with schematic nameplate marking. Motor shown on schematic shall show HP, frame, RPM, volts, and amps. Any black box shown on schematic shall show in the material list the manufacturer's number of the device along with its diagram and instruction book number. Electrical, hydraulic, pneumatic, and lubrication diagrams are cross-referenced on drawings. All programmable controller printouts shall be labeled as to I/O numbers and functions. Included with the PLC program will be a file allocation and usage description. The cross-reference shall include descriptions for all internal bits, integers, timers, and counters. Maximum size of sheet shall be 24 inches by 36 inches, excluding machine layout. All sheets shall be of the same uniform size. Combination motor starters. Combination starters shall be of the fusible type, minimum size 0 with 3 overload devices in a NEMA 12 enclosure. No holes are to be cut in the top of starter enclosure. Disconnect switches. Non-fusible disconnect switches shall be installed at all remote motor locations. Disconnects shall have a NO and NC interlock. The NO interlock shall make last and open first when the disconnect is operated and shall be wired into the motor starter control circuit. E-stop circuits. The E-stop circuit will be safety wired per OSHA and Michigan OSHA. The E-stop circuit will have at least one reset push button to reset the circuit. Resetting individual E-stop PBs shall not re-enable machine operation. The robot controller shall be wired into the E-stop circuit. All robot motion must stop immediately. The entire E-stop circuit must be hardwired with a safety relay or equivalent. A PLC shall not be used for the E-stop switches or the safety relay. The relay IDISC RU2SD24. The relay will be used for plant star system, real-time plant floor data acquisition system open and closed circuit for part count only. The following is for the ergonomic product variables. All machine-mounted devices shall be readily accessible per good ergonomic practices. Conduits, hydraulic piping, or machine sections shall not limit the accessibility. The goal of Amer workstation design is to promote ease and efficiency for the person working. Productivity relative to both quality and quantity will be enhanced if the operator is comfortable, and if the layout of the workstation is conducive to performing the task well. Keeping this in mind, Amer advises to establish an ideal workstation and work environment first and to make concessions to practical limitations only if absolutely necessary.